To find average velocity here, we want to use the average rate of change formula. So we're going to evaluate h at 2 seconds minus h at 1 second divided by the time elapsed, 2 minus 1 seconds. From here, we'll plug in 2 to our function. Minus evaluate at 1 second, so plug in 1 for t. All over 2 minus 1, which is 1. And then simplify this, get 12.56 minus 8.14, which gives us 4.42 meters per second as our average velocity between 1 and 2 seconds. Next, we want to find the instantaneous velocity at t equals a seconds. As h approaches 0 of the function evaluated at a plus h minus h of a over h. Next, can plug in our values. We have 10 times a plus h minus 1.86 a plus h squared minus 10a minus 1.86 a squared all over h. Now we can clean this up a little bit. 10a plus 10h minus 1.86. Let's square the binomial. Minus 10a plus 1.86 a squared all over h. Next, we can remove the parentheses. Next, we'll combine like terms, leaving us with 10h minus 3.72ah minus 1.86h squared all over h. We can remove an h from the numerator and denominator, leaving us with the limit as h approaches 0 of 10 minus 3.72a minus 1.86h. Now h is going away to 0, so we're left with 10 minus 3.72a. So we now have the instantaneous velocity at any given time a. Instantaneous velocity at time equals 1 second. Since we have a generic formula, we just need to plug in 1. 10 minus 3.72 times 1 will give us 6.28 meters per second. Velocity at time 2. Again, we'll just plug in 2 for our time of a. This will give us 2.56 meters per second. When will the rock hit the surface? The rock hits the surface when our h value, which is, again, 10t minus 1.86 t squared, when that is equal to 0. So we can factor out a t. Set each of those factors equal to 0. And it looks like at 0 seconds it's on the ground, and at roughly 5.4 seconds it's on the ground. If we wanted the exact value here, we could rewrite this as time equals 10 over 1.86. Earlier we found that the velocity is 10 minus 3.72 a for seconds. So we want to know what is that when your time a is, let's use the exact value so we don't get rounding errors. So it looks like we get -10, and that will be meters per second.